moving in a retrograde trajectory opposite to the motion of the planets, which is ideal for it to release mini probes that will get into the planets. It gets close to Mars, it gets close to Jupiter, it goes on the opposite side of the Sun relative to Earth when it's closest to the Sun, and that's the time when a spacecraft could do a maneuver to take advantage of the Sun's gravitational assist. You know, all of these are interesting indications that may imply that some intelligence designed the trajectory. So maybe the trajectory was designed.
This week, a 5-kilometer wide object, possibly more, will slip behind the Sunday, not figuratively, literally. For 8 full days, it will vanish from Earth's view. Telescopes will be blind. Our sensors are overwhelmed by solar radiation, and during that blackout, no one, not NASA, not the ESA, not even AI tracking systems, will be able to monitor what happens next. But here's what's terrifying. When it re-emerges, it will be parked at its closest point to the Sunday A zone. Astronomers call perihelion. And at that moment, it'll be absorbing over 33 gigawatts of solar energy, a level of radiant power comparable to lighting up an entire country. That's more energy in one moment than all but a handful of human-built reactors have ever handled. And it won't just be floating there, it'll be moving, fast, nearly 60 kilometers per second. So, why does this matter? Because some researchers, including Avi Loeb from Harvard, say we have to stop assuming it's just a natural rock. Its trajectory, its timing, its composition. None of it fits cleanly into what we know about comets, which leads to a far more serious possibility. What if this thing is using the sun as cover? What if this entire maneuver was planned? And we're not talking about years or decades away. We're just days from it disappearing, and no one can say with certainty what it's going to do while it's out of sight. October 21st to the 29th, that's the critical window. For those 8 days, 3I Atlas will be on the far side of the sun, completely invisible to Earth-based telescopes. It won't matter how powerful your lens is. You won't see it. Not from the ground, not even from space. The Hubble Space Telescope, blinded. James Webb, too close to the sun's glare. It's a full observational blackout. And for 8 days, 3I Atlas will have the skies all to itself. But the timing? That's what's raising alarm bells. This isn't just any random moment in its journey. On October 29, precisely at the tail end of that blackout, 3I Atlas hits perihelion, its closest point to the Sunday, its fastest velocity, its highest energy state. That's not just a celestial milestone, it's a potential ignition point. Now here's the twist. In astronautics, if you want to execute a burn, make a maneuver, or release something, you do it at perihelion. It's the most efficient spot in the orbit to dump energy. It's basic physics known as the Oberth effect. You get more propulsion for less fuel if you act when you're moving fastest, near a massive body like the Sunday. Every serious space agency knows this, and every serious mission is planned around it. So ask yourself, what if this isn't just orbital coincidence? What if this timing, this exact alignment of invisibility and maximum energy, is the moment something's meant to happen? A deployment? A course change? A deceleration? The conditions are perfect. The cover is perfect. The question is, was it designed that way? Let's talk raw power. When 3I Atlas reaches perihelion on October 29th, it won't just be close to the sun, it'll be drenched in solar radiation. Scientists estimate the sunlight hitting its surface at that point will exceed 33 gigawatts. That's not a typo. That's 33 billion watts of real, usable energy focused directly onto a single object. To put that in perspective, that's enough power to keep 24 to 25 million U.S. homes fully lit and running. Or, if you want to get more tactical, that's enough juice to power a planetary defense laser, a deep space propulsion system, or an energy-hungry